Off with that today is one of the most important things that we are going to learn in geometry. So this week is one of my favorite units, part of the unit, and then the week after we learn about trigonometry. Those two things are my favorite part of geometry. This stuff is directly related to pre-cal and calculus, and it's also going to help you guys out with physics. So it's some awesome stuff, if you ask me. If you guys had any questions on 5.1 and 5.2 and you're not in class today, just fill out this form and I will do a video for those things if you're not in class. Okay, so just let me know. So first thing I want to talk about is just the 45, 45, 90 and the 30, 60, 90 triangles. Okay, so we have two different types of special right triangles, 45, 45, 90. The reason why these are called 45, 45, 90 is because two of the angles are 45 degrees and one of the angles is 90 degrees. Well, what happens is this comes from a square. When I look at a square and I draw in a square's diagonal, what happens is since all the angles are 90 degrees in a square, this angle now becomes a 45-degree angle. This angle over here is also going to be 45. This is the Mac Daddy of all right triangles, the 45, 45, 90 triangle. It's an isosceles right triangle. Both sides are the same. So if we know both sides are the same, then what I'm going to do is I'm going to put S and S on these two sides for side and side. Let's solve for the hypotenuse. Let's call that C. So I can do S squared. If I want to use Pythagorean theorem to solve for the hypotenuse, that's S squared plus S squared equals C squared. S squared plus S squared, that's 2S squared. That's going to equal C squared. Now we're solving for C. Since we're solving for C, we want to get C by itself, so that means we have to get rid of the square root sign to get rid of the squared sign. To get rid of the squared sign, we're going to take the square root of both sides. Now remember, when you take the square root of two things that are multiplied together, we take the square root of 2, then we times it by the square root of S squared. Okay, we separate them out. That's going to equal C. When I look at these two things, S squared is actually just regular S, because remember the S squared, that's S times S, and the squared sign cancels out with the radical sign, and then you have the square root of 2 that equals C. This is what this reduces to. So basically, whenever you have a triangle and it's a right triangle, do my best to make it a 45, 45, 90. Okay, whenever you have a triangle and it's a right triangle, and we know that either two of the legs are the same size, or we know that both angles are 45 degrees, they're the same, then we always label our triangle S, S, S square roots of 2. This is a pattern that Pythagoras came up with a long time ago. Now, if you don't like using S's, you can use X's or A's or B's or whatever you want to use. I just use S's because when we get to area, to find the area of a square, it's side squared. So you can use whatever variable you want. Now, if you don't get all this stuff that we did over here to find out what the hypotenuse is going to be, that's okay. What I need you to know is this is how we always label a 45, 45, 90 triangle. We'll do some examples of this tomorrow. This is just the main basic information. I didn't want to get into too much today because I know that there's going to be a lot of questions over 5.1 and 5.2, so I wanted to take those questions today in class. Basically, this is another type of special right triangle because it follows a specific pattern like the 45, 45, 90 triangle. If I have an equilateral triangle, let's say this triangle you're looking at right now is equilateral. What that means is this angle here is going to be 60 degrees because all the angles inside of an equilateral triangle are 60 degrees. Well, what happens when I draw in the altitude? If I draw my altitude in straight down, that makes a 90-degree angle, which creates this right triangle right here. Since one of the angles is 60 degrees, one of the angles is 90, how many degrees is this angle up here going to be? It has to be 30 degrees. So we just took an equilateral triangle and we created a 30, 60, 90 triangle from that. What's really important about this 30, 60, 90 triangle is this. If I label the shortest leg, which is across from the 30-degree angle, let's say I labeled this leg A. So in my original picture, that would be the length right here. Well, my original picture had an equilateral triangle. On the equilateral triangle, if I labeled that leg A, how long is the entire bottom of this equilateral triangle? Both sides are A, so that's A plus A, which is 2A. What this means is all the sides of this equilateral triangle have to be the same. So the hypotenuse of my 30, 60, 90 triangle is a full length of my equilateral triangle. So this also has to be 2A. So in my picture, the shortest leg is A, and the hypotenuse will always be labeled 2A. We can do Pythagorean theorem to figure out what the length of the altitude is, or the height of this triangle. We'll call this B. So if I do Pythagorean theorem here, I get A squared plus B squared equals 2A squared. That's A squared plus B squared equals 2A squared is 4A squared, right? 2A times 2A is 4 times A squared. I'm going to subtract a 1A squared to the other side. And I get B squared equals 4A squared minus 1A squared is 3A squared. And then I'm going to take the square root of both sides. So I'm going to get B equals, that's the square root of 3 times the square root of A squared. And just like the problem before this, the square root of A squared, the square root sign and the square sign cancel. So we're left with A square roots of 3. This is a proof just to prove to you guys that whenever I have a 30, 60, 90 triangle, the short leg gets A, the longer leg will always be labeled A square roots of 3, and the hypotenuse is 2A. This is how we always label a 30, 60, 90 triangle. This is a pattern that was created or found out by a mathematician back in the day. He found this pattern anytime he had a triangle that was a 30, 60, 90 triangle.